I had a lot of interest in software tools to facilitate the development of user interfaces, to make it easier to build user interfaces, because it was very time consuming. I developed something called the User Interface Design Environment, which was a set of tools that were designed to make it easier to build UIs. One of the nice capabilities was being able to provide context-sensitive, animated, and verbal help to users. If I would pose a question, how do I do such and such, the system would do some reasoning based on backchaining and show by moving the mouse around on the screen and also speaking what I should do to carry out the goal that I had in mind. Okay. The goal of UART was to both simplify and speed up the building of user interfaces, at the same time making the user interfaces be better for the end user by having these sorts of help capabilities built in, rather than having to add them on as a separate undertaking by the software developers. UID was what we call a model-based user interface development tool. The idea of an underlying model with some semantic information has now been picked up in what we call responsive user interfaces for the web, where there's an underlying model that allows the adaptation to little iPhones or to big screens.
We are building a user interface management system which is driven by an object action attribute model of the application. The model can be transformed at design time to explore different user interface designs. Here we see the designer changing defaults for parameters. Other changes include bundling attributes, as is done with word processor style sheets, changing interaction styles, changing the type of feedback, or including object naming as an end-user capability. Now we are requesting execution of the application. Here we see the application in the upper right window, surrounded by a command window and several dialog boxes. The user selects an object, and its default parameter values are automatically inserted into the dialog box. The system supports rapid iterative design of user interfaces.
So when I was a student in GVU, my project was the Mercator project, and we were given actually by the Center for Assistive Technologies the challenge of how to make graphical visual interfaces accessible to people who were blind. And again, remember, this is even before the web. Graphical interfaces are just starting to appear. There's even a motion within the blind community to try to outlaw graphical interfaces because they're so inaccessible. And it's a huge crisis within the field. So we banded together a team that worked with the NSA and Sun Microsystems and NASA to create technologies that would translate and model a graphical interface and create a completely different auditory interface for blind computer users. The impact of this was tremendous in multiple ways. First is we became the demonstration to show that this was possible. So we were part of the conversation to say, no, computer makers, the IBMs, and then eventually the Microsofts of the world, your interfaces can be accessible, and here's the pathway to do it. And then the code that we wrote actually became part of X Windows, which was the dominant system at the time, and is now part of every Java Swing library that's being used today.
So the first project that I worked on whenever I was a graduate student, and it turned out to be the first paper I ever published, was on an email system actually. And it was one of the earliest multimedia email systems. So for the old timers that are out there, you know, email used to be very text oriented. You would do it in a terminal with a green screen and you would type commands and so forth. And so I had built an email program that actually ran as a graphical user interface on a computer. And beyond that, actually lets you include different kinds of information. You could have video and you could have pictures and you could have sounds as part of your email messages. And it's something that we really take for granted now because, of course, all email works this way. But at the time, it was a really fun system to play around with. It wasn't the first, but it was the first to do email in a particular kind of way, extensible sort of way like this. And so that was a really fun project for me. I think that the vision that we had of the way that the future would be whenever we worked on this project was that it would move beyond text and be full of rich media, and people would be able to communicate and collaborate more fluidly because they would have this rich media that they could exchange with each other. And I think that vision has really come true.
A Unix and motif-based multimedia electronic mail system. Montage supports composition, transmission, and viewing of complex multi-part multimedia documents. A Montage message consists of a main body and any number of attachments or annotations which are analogous to margin notes on a paper document. Components in the main body and annotations can be of any media type. Unlike some other mail systems, Montage is completely extensible at runtime without the need to recompile. Montage supports arbitrary media, including text, graphics, audio, video, and even executable programs. To enable support for new medium, users bring up the Media Configuration panel and fill in a number of attributes for each medium. Settable attributes include external programs which may be used to display and filter message components. Montage can use applications already familiar to users to compose and display messages. Compression configuration can also be used to select compression algorithms to be used on a per-medium basis. Montage is a general tool which supports very rich communication between users and can be used to facilitate group work in a wide range of settings. The Virtual X shared window system allows unmodified X Windows applications to be run in a multi-user environment, thus supporting computer-supported cooperative work, group document editing, and other collaborative tasks. Here we are running the FrameMaker document preparation system. FrameMaker executes on one workstation, but is displayed in Windows on 2 workstations. Virtual X supports multiple collaboration policies by allowing an external program to be used to control the floor. This floor control manager is pictured here in the lower right corner of the left workstation and in the upper right corner of the right workstation. This policy is to allow any user to grab the floor whenever he would like to become the active user. Once he does so, as in this example on the right workstation is now in control of the session, and its input is directed to FrameMaker.